about analytics for your ZOS storage infrastructure. We did last month we did a webinar that had a very similar title on the systems. So if you do have responsibilities across other areas of the infrastructure, you might want to go and look at that one as well to see some of the new infrastructure capabilities in systems and networking. But today our focus is only on the ZOS storage infrastructure. So we will talk about, first of all, the what, why, and how of modernizing RMF and SMF usage with a focus on performance and capacity planning for the disk infrastructure as well as the virtual tape infrastructure. So I'll cover that, and then we'll switch over to Lee LaFries, who will walk through some use cases for disk analytics, for replication analytics, and virtual tape analytics. And then hopefully we have time for questions as well. As Morgan said, you can submit questions via the interface, and if we don't have time to get to all the questions, go ahead and submit it anyway, and we will respond to that after the webinar. But hopefully we'll be able to address your questions as well. Why modernize? How you use RMF and SMF. This is a slide that kind of goes through really the essence of why we think there needs to be a new approach to understanding the storage infrastructure out of the rich source of RMF and SMF data that's provided. And essentially it's about the effectiveness and efficiency of, first of all, just delivering the service levels for the applications that are dependent upon the storage infrastructure. So continuous availability to be able to predict and prevent disruptions that are caused, that can be caused by the slowdowns in the storage infrastructure for a variety of reasons. And when issues happen, how quickly can the problem be solved, whether it's been predicted ahead of time or whether it's a current active problem that was not able to be predicted for because of the type of problem it is. How much intelligence can you get out of the data in order to solve that problem more effectively and more quickly? From an efficiency standpoint, that's really, we're talking about cost efficiency here on the infrastructure. How do we deliver the service levels and save money at the same time? So we're not really going to talk about it in this particular webinar. But IntelliMagic does provide performance modeling of all of the disk subsystems that you can purchase for the ZOS environment. So you can model your own workloads on the hardware that you're thinking about buying. And we have experiences, documented experiences with customers who have engaged these kind of performance modeling services where they were able to save some significant dollars by purchasing an alternative configuration than what the vendors were recommending that they purchase and not suffer any negative performance ramifications of that. So you might inquire if you have some interest in that, if you have a storage tech refresh coming up. That can be a very interesting experience. It's also a value to actually use the performance modeling capabilities on when you're migrating workload or consolidating workloads from one location to another location, just to make sure that the target arrays can handle the work that you're doing for it. The other reductions are more on the system side. That's why it says MLC there. That's not really applicable to this particular webinar. That's focused on the storage infrastructure only. On the IT staff side, we believe that taking a different approach to the RMF and SMF data will also help bridge the skills gap, which we all know is an issue there. It's difficult to come up to speed on the platform, and we do have people with deep expertise that are retiring and so on and so forth. So one of our approaches that you'll see today is to include a lot of expert knowledge in the product and recommendations and ratings about what's good and bad, and this can really help come up to speed. Both experts like it because they know how time-consuming it can be to go and get that same kind of intelligence in a manual way through just static reports, and new people like it because it really helps them focus on what's most important in in all the data, and to understand the recommendations of why IntelliMagic thinks it's important is a good way to come up to speed. Job security is mentioned there just because I think the more efficient we are, the less likely these applications are going to get migrated to another platform besides the mainframe or to get outsourced and these kind of things. So we really believe strongly that this is good for the team to operationalize the data using artificial intelligence, basically to drive better intelligence out of the data than is really obtainable using status quo methods today. And that's essentially the nature of the problem as we see it in talking to sites all across the country, or even different countries as well, is that the processes used to understand what the data means for your applications running on your storage infrastructure. I mean, these processes were designed 4 decades ago, by and large. And even if it's you know, some of the nicer looking reports, like over on the right-hand side of the screen, that happens to be a systems chart, not a storage chart, but we'll get to the storage data. Those are static reports, and it might look nice, but if you have hundreds of these reports you have to look through, there's no indication about whether it's good or bad what you're looking at, so there's no ratings. Typically these charts are not, you can't click on them to drill down and go to the underlying issues, so on and so forth. So hopefully you'll see some of that and some of the differences. It may be a little deceiving if you just compare 2 charts on a PowerPoint slide, but we encourage you to actually, you know, hopefully we'll show you enough and it's interesting enough that you can go to the next step and send us some data and then see how interactive it is and how powerful the ratings are. To be able to highlight automatically what's important in the data for your site and advance the state of the art. Where these cell phone and punch cards, I mean, as great as those things were when they came out, nobody's using devices like those today, yet we're still kind of stuck with a lot of static reports that have to be coded for each new kind of chart that you want to see, a new record type that's released by IBM on the SMF, RMF data, or the other storage vendor, whoever you're using. So it's in short, ineffective and inefficient to find out what the data means for your applications on your storage infrastructure. So we think in this day and age, we're in the era where we expect more from the computers. And this is a quote I like from Kevin Kelly on really the roles of machines and humans. And the humans should be asking the questions and making the computer do the laborious work of finding the answers for us and sorting through the data and figuring out what's important. And of course, we use our cell phones this way, right? You can ask Google or Siri on the Apple different questions, and they'll go out and pull different information for you. And that's kind of the concept that we're trying to get to here on the mainframe platform and managing the storage infrastructure. So it's not really a human versus machine thing, it's really human and machine versus the problem. We can be better together when we're both doing what we do best. And the computer is very good at sorting through reams and reams of data and comparing it and checking for different conditions and highlighting different things that can be brought to the attention of the human analyst, who can focus on you know, the analysis and the planning and the implementation of solutions to avoid predictively you know, predict things and avoid those problems, or to solve problems, and so on and so forth. So that's the real objective that we're trying to address with this concept of modernizing how you approach the data to get better answers out of the RMF and SMF data, make the computer do more work for you. So what kind of things can it answer for you? I mean, what risky conditions exist right now across the entire environment? I mean, this is a very difficult question, and I've been in many different shops all over, and it's not a question that sites are able to answer very easily. Because of the way that we're reporting on the data and what the data means for you know, the service level delivery that for the different applications and the demands that it's placing on the infrastructure. So we do this with automated rules. We actually have over 400 different types of health checks that we are constantly evaluating the data for and summarizing them in a what we call an exception table. Don't know if you can see this real well. This actually happens to be one for the coupling facility, not for the storage infrastructure. But we actually started, if you know any of our history, we started in the disk analytics area years ago, and then into asynchronous replication and synchronous replication, and then the virtual tape and the systems infrastructures later for us. So most of our health check rules or a good portion of them anyway do certainly apply to the I/O infrastructure, and you'll see that in the chart. And what we do is not just flag these exceptions that we think somebody needs to take a look at and rate them by severity, but provide these dashboards with these dots on it in the middle there, where the different metrics, each dot essentially represents an individual rated chart, and you can click and drill down and continue and drill down to the relevant issues and ratings that are there. So where do you want to go see, what do you want to go see next to understand the root cause? We anticipate that kind of thing based on the condition that's occurring, and present that in this interactive tool. So including the recommendations has been very powerful for our users as well, to understand why is this an issue and what should I look at in order to create a solution to remove this particular bottleneck or issue. So, if you want to get to better answers, one of the things that you're going to achieve is being able to ask higher value questions. So, in the course of time, when a problem does occur on the storage infrastructure that affects the production applications, today it's good to be able to use the data to answer what went wrong, basically a post-mortem analysis, and that's the most common use of from a performance team for the RMF and SMF data today, gathering together the different data and reports and trying to figure out with different experts, is this a configuration issue, a change, a microcode change, is it a change in the application, is it a failure, the fiber or the switches or whatever, the internals of the disk subsystem, where there's some components that became overloaded. You can do that. It can take a lot of time, but that's a good use of the data. A better use of the data is if you're loading the data much more frequently. Our best practice is like once per hour, for example, so you have a fresh situation there. Something's going on that can't be predicted, in particular because it was a sudden application change or something of that nature. Being able to get easy visibility about what's going wrong right now, and drill down and to see what's being flagged so that the problem can be resolved more quickly. And then, of course, the best is the predictive aspect of it, being able to ask the computer the questions to determine what's about to go wrong and how can I prevent it. That's obviously the most powerful, the best for providing the continuous availability for your applications from the infrastructure, and it's very doable if you have a solution that has the built-in expert knowledge to automatically evaluate all the different aspects of the storage infrastructure, from the switches and the connections and the ports, and how many megabytes per second are flowing through each port compared to how many megabytes of throughput can those ports handle before they start to introduce delays into the service times, for example, or on the internals of the disk subsystem, from the reads and writes, whether it's flash or spinning disk or whatever. These are complicated devices, and you have to have an understanding of how the architecture works for that particular hardware and how it responds to the workloads that you're driving to it and expecting it to handle. So those kind of things should be checked, and these are the kind of things that are just virtually impossible for teams to do today, using the antiquated ways of looking at static reports on RMF and SMF data. The computer needs to be checking a lot of these things for you and presenting the intelligence to you to say, hey, this is important and somebody needs to take a look at this in order to prevent it. So that's our objective with these, and it comes in this area that we call ITOA, IT Operation Analytics. It's an industry kind of standard terminology out there. There's a lot of products in this area. Most of them don't have any ZOS specific knowledge built into them. So there's some value on doing statistical analysis in the data, of recognizing anomalies and correlating different peaks in the data. But if you really don't know what the capabilities of the hardware are that you're running, you're going to miss out on most of the value that I'm talking about here. So in this definition from Forrester Research of analytics, the other innovations is highlighted here, really to highlight this particular point. of working hard to build in ZOS-specific expert knowledge about the infrastructure you're using and the ZOS different workload types and how they stress the different components, so on and so forth. This is the key for really delivering a new user experience to be able to become predictive and to get the computer answering these kind of questions. And this is a form of artificial intelligence, making the computer do things that does require intelligence if a human is doing it, and just it also requires tons of time that nobody has to do. So the process is really, taking all of this data and reducing it down into information and then into intelligence through additional analysis and production, and until you have some actionable intelligence saying this is what's important, and that's how you're going to increase the effectiveness and the efficiency of delivering the availability services on a 24/7 basis, or whatever your requirements are for your particular production applications. So today, I mean, with the antiquated reporting processes that most people are using, most of the reports are actually created automatically, so you don't have to spend a lot of time doing that unless there's new record types or changes to the reports, and then it requires programming a lot of times, or even worse, if you're using a vendor to deliver these reports to you and they're static reports that can't be customized on the fly, then that can lead to a lot of time spent there. And IBM has actually been doing a good job lately about increasing the number of records that are available for different things, like ZEDC, for example, on compression and so on. I mean, there are new record types coming on board that need to be reported on, that are important for delivering the service levels that you require. But historically, most of the time has been spent in actually taking the reports and then trying to figure out, what do these mean? Is this good or is this bad? What's going on? What's changed? So on and so forth. And this is just, it's so time consuming and requires so much expertise. It's not done today until after a production problem actually occurs. So we think that needs to change, and the computer should be doing that, as we've been saying. So most of the time is spent there, and we think most of the time for the teams really needs to be spent on the analysis and remediation and planning and so on and so forth. And that's how we're going to be able to continue to deliver the service levels, even in the complexity of the environments that we have today. So this is the way we do it. I'm not going to spend time on this because we're already about 20 minutes after, and we need to get over to Lee on the use cases, but we have whole presentations on how this ZOX specific expert knowledge has been built into the process to calculate additional metrics and prepare the data, normalize the data, and all these kind of things. But we'll show you the end result through our dashboards, like I already mentioned. Basically, what we're trying to do here is to operationalize the data, to enable new uses for performance management of the storage infrastructure, in this case, become more predictive, seeing issues sooner than real-time problems happen with these kind of ratings. We also do some work to segment the workloads into applications or groups of applications, so that you can, if you have some loved applications, you can easily see, is this application being affected by anything going on in the storage infrastructure, or is it about to be impacted, or is the health of the storage infrastructure good and there's no current concerns in it for that particular application. The other thing that does is allow us to open up new users for the data. For example, DevOps, and if you have an agile development group that are developing and changing applications on a frequent basis, those groups typically don't have a very good understanding of the impact on the ZOS infrastructure of their programming changes, and they do their own testing of the application, but it typically does not include how the impact on the infrastructure has changed from one version to another with the same test workloads. We can do that by this application segmentation, along with some other features like the automatic compare function of one date versus another, which can be two different versions of it. So anyway, we're doing a presentation at Share next month on that particular topic. We do have some customers that have business application owners that are interested in getting their daily infrastructure health summary and dashboards for their applications on how the infrastructure is delivering it. So it's kind of some interesting new uses of the data by this modernization effort. We're also investing and working with customers in some of these other areas for capacity planning and show back and charge back and so on. So if these are on your plate currently, it would probably be good to have a discussion with some of the folks on our team to see how we might be able to make that an easier process for you. Finally, this is my last slide just to help you understand how are we delivering this modernization to our customers. And this is a software as a service implementation diagram. Basically, it's surprising how easy and quick it is for customers just to start sending us some data. Again, the best practice is for our software as a service customers is to automate the FTP of the data to us. It's mostly RMF and SMF, but there's other things like decollect, or if you're talking about the virtual tape environment, like an IBM TS7700 environment has BVIR data. That's where we get the knowledge about the utilization of the physical components in the virtual tape devices. Same kind of thing applies to Oracle as well. We take that data and process it with this reporting engine and ratings engine and so on, and then anybody within your organization can use the web reporter to see it, just like as if it was on premise. We also will often provide services to advise customers on what the data means and how to use it for, an initial training kind of time frame, or even to compare notes with our technical experts on what other customers are experiencing and seeing and so on and so forth. It's nice to have access to resources like we have on staff, like Lee, for example, who has a really deep expertise and seen a lot of things at a lot of different sites. So if you do have some security requirements that require it only to be installed on premise, we do that, but this is really a best practice to use the software as a service. We find our customers using this delivery of the software get a lot more value out of it typically than other customers that have it on premise. In terms of us managing the software, it's always up to date, managing the database, managing the file transfers, and make sure it's all processed and the analytics are created as needed. So with that, I'd like to switch over and have Lee walk through some use cases for us. Are you ready for that, Lee?
I sure am.
Okay.
Okay, let's go. Good morning, everyone. First, we're going to take a look at this roadmap. I'm going to show you 4 different use cases. The first 2 are related to ZOS disk, and the third one is ZOS replication using ZOS disk, and the last one is ZOS tape. So you can advance the slide, please. Next slide. There we go. All right. So the first case study will help you understand how we use dashboards and ratings that are going to provide you early warning about issues in your storage infrastructure. It's also going to help you facilitate the finding of the source of the issue via a series of intuitive drill downs. You're going to see how in just a few minutes you can go from a box level warning to understanding exactly which specific data sets and jobs are causing a metric to be elevated. So let's go to the next slide, please. Okay, so this is all these examples I'm going to show you are actual customer data. We've anonymized it, so we've changed the names of the storage systems, the names of the systems, the host systems. We've changed the dates in some cases to try to, protect the guilty. But this is real actual customer examples. It's not made up data. And in this particular case, we have a customer that has 4 disk storage systems in the environment. And what we have here is a disk storage system dashboard. If you look on the left, you see the names of the 4 disk storage system, and across the top are the metrics that we're tracking. Okay, so those are the key metrics that help describe the health of the storage system. We also have a rating in brackets at the top. In this case, the rating of 0.13, and we'll talk more about that later. And then we have a bunch of green dots, some blue dots, and a couple of yellow dots in this case. The blue dots are indicating only the intensity. In this case, the I/O rate. We're only telling you how intense is the I/O coming from the storage. And we have two that are fairly intense and two boxes that are not that intense. All the green dots, those are just there to tell you that things are healthy. Those metrics, nothing is out of the ordinary on. Now these yellow dots are very powerful because they're giving you the early warnings. And we see two yellow dots here in this environment. One on one storage system, it's for the read hit percentage. And on the bottom storage system, which is Z902, we see a yellow dot for the connect time. So we're going to look at this issue and we're going to try to figure out, starting from this dashboard, what's going on here? What's causing this issue? So next slide, please. By clicking on that line in the dashboard, we bring up a multi-chart with all those key metrics. So you can kind of get a visual here on all the metrics that we were tracking in the dashboard. And we notice all of these metrics pretty much have green borders, meaning that things are healthy. But the connect time, just like the dot, we have a yellow border around there. So that's the chart we want to focus on. So we're going to just click on it and go to the next chart. So just by clicking on that chart in the multi-chart, you bring up a full-size chart of the connect time. Now it's interesting to look here because you see there's a yellow border. You see that rating of the 0.13. And you notice that the metric is kind of flitting back and forth between that light gray and then the white or beige area below it. What we have here is an example of dynamic thresholds. We actually, that's part of the intelligence that Brent was talking about. We model what your connect time should be for the workload and hardware that you have in place. And then we create these thresholds based on those models. The top zone, the very dark zone, that's the red zone or performance exception zone. The lighter gray zone is the early warning or yellow zone, and then the bottom is the healthy zone of the chart. We call that the sunny area as opposed to the cloudy or stormy area. And you can see that we're frequently jumping into that yellow zone, and we're doing it often enough to create an early warning. And basically what this chart is saying is that 13% of the time, that's the 1.13, we're getting up into that early warning area. And that's enough to flag it as an issue. So let's move to the next chart, please. So what we do from there is we drill down and we're trying to see, is there a particular SSID on the storage system? And it was just a click. You just click on the connect time, you set the drill down to SSID, and suddenly you will get all the SSIDs on the storage box, and all of them are rated for connect time. And interestingly enough, when we do that drill down, we see one SSID that has a red rating. All the other SSIDs are healthy. And you can see that because on the right, there's the list of SSIDs, and the only one that's bolded is the one that has too high a rating and is actually red. So we actually help you narrow it down very quickly by seeing that one highlighted SSID. So this is a kind of a noisy chart. You really can't see that SSID's response time. You do see some other SSIDs that have very high connect time, but they're not rated badly, and you might ask why. That's because our ratings take into account the activity on the SSID. If there's really no significant activity on the SSID, then it won't be rated. If there's a lot of activity, then it would be rated. Also, the workload may be moving large chunks of data, so the connect time is expected to be high. So we take all that into account in the thresholds. So from here, we can hit the isolate. You can see the isolate drill down, and let's move to the next chart. So now we see just the connect time for the SSID in question, SSID 6000. And we see, yeah, that's getting up into that early warning zone quite frequently. And why, you may say, it's never getting into the dark, stormy area. Why is it red? Well, the reason is it's 41% of the time it's in the warning zone. And once we get to more than 30% of the time in the warning, we're going to flag that as red, even though it really never gets to that warning. Because too often you're getting high connect time, and that should be flagged. So from here, we'd like to see, hey, are there specific volumes that are involved? So we can do a drill down to the active volumes. So let's go to the next chart now. And here we see that we've got one volume, VolSeer 933, that is red. All the other VolSeers are clean. So again, we have narrowed it down as to where this connect time issue is coming from. So from here, we can drill down further. We can go down and we can see, are there specific data sets on that volume that are causing the issues? So let's move to the next slide. And now you can see, this is kind of a little hard to see because it's a dot chart, because data sets are not always active, and the data is collected on an hourly basis. And we see that there are two data sets on this volume. One of them has very low connect time, but the other one has elevated connect time. It has it at certain times of the day. So we know that the specific data set that's driving the high connect time. From here, we can find out, it would be nice to know more information about what's going on with this data set. So we can find out a lot more by using the identify drill down. So let's move to the next chart here. Okay, now the identify drill down provides a wealth of information about the volume and the data set. We find out that the volume is a 3990 mod 27. It's in the specific storage group SSD 3828. We find out that the data set in question is a KSDS data set in its extended format. We can see the address space names that are accessing this data set. We also see that the workload is, the storage class is team. We see the service classes that are involved, and we see that the workload is mostly batch. So it's pretty easy here to figure out, and you can see the two circled address spaces that have elevated connect time. So these are likely the jobs that are driving these high connect times. Now, the next question becomes, are these normal or are these not normal? And from there, if they're not normal, something can be done to address it by looking at these address spaces and figuring out what jobs are running there. Or it may be a case where this is acceptable and we can adjust thresholds in that case. So let's move to the next slide. So, the big question is how does this help you? What are the operational benefits of being able to do this? Well, the first one is visibility. I would bet you in most cases you wouldn't even see this as an issue. You wouldn't even know it was happening unless the people that were running those jobs were screaming about poor performance. So we're able to quickly and automatically flag and identify the issue. That's very valuable. The next thing is the drill downs. These drill downs made life very easy. Just in a few minutes, you can easily find the affected SSID, volume, the data set, and even the jobs and address spaces involved. Normally, this would involve iteratively running many MXG reports, for example. It just would not be that easy. So anyway, that's basically it for the first case study. We're going to move on to another interesting case study. And this is a situation that I'm sure you find yourself in. Every shop will upgrade their storage from time to time. Storage, upgrades typically are every 2, 3, or 4 years. And you're always going to be introducing new technology. Ideally, it will help you improve your performance and your availability. When you do a migration, you can often get either a performance guarantee or a performance estimate from your storage vendor when they roll in the new hardware. But the question is how can you be sure that the new hardware is actually meeting your expectations? And what if some of the sometimes you have a configuration error or other issue during the early stages of the install that is going to affect your performance or availability. You have to really keep a careful eye on your performance during the migration. Otherwise, you may not get what you paid for. Next slide, please. So here we have an example where a customer was migrating to new storage. And the question they had is, did performance improvements actually meet expectations? Before the migration, they had two VMAX 20K storage units with synchronous replication. And after their target configuration was one VMAX 200K with SRDFA replication. That's a VMAX 3, by the way, in case you didn't know. So they were switching replication, and they were also going to a more recent vintage of EMC storage. And this is a chart that you see from IntelliMagic Vision that kind of tells you a history of changes that you have in your environment. So that's an example of the kind of information you can get if you're running IntelliMagic Vision. You can see serial numbers deleted, serial numbers added, number of volumes being changed, etc. Now, in this case, when the EMC, the storage vendor, estimated that the resulting response time would improve by about 40% after the migration. This is partially due to the switch from synchronous to asynchronous replication, but most of it is due to the larger cache because they went from 2 boxes at 215 gigabytes of cache to 1 box at 888 gigs. So they're increasing the cache, and also the faster hardware that you have on the new VMAX 3. So next slide, please. We also can track things a bit like allocated space growth. So this is an example of that. And I'm just using this chart to show you when the migration occurred. You can see that they had the 2 storage boxes we call EMC 1 and 2 before, and then about November 20th is when they switched over to their new VMAX 3 hardware. So it's just illustrative of when it happened. So keep that date in mind, November 20th. We're going to talk about it again. And you can see that the allocated capacity on the sum of the capacity on the 2 existing boxes is about the same as the allocated capacity in the new box. Advance the slide, please. Next slide. Okay, so the customer is really interested in seeing, did this really improve my performance? How much did it improve things? They want to quantify the benefits of this new storage hardware. So it's kind of easy to do a comparison and look at throughput. So here we're looking at the overall throughput in megabytes per second of the old storage infrastructure compared to the new. And that's a nice feature of IntelliMagic Vision, is that we have this very powerful compare feature. So we're looking at the week of data immediately following the migration and comparing it to the week of data just before the migration. And what do we see? We see about a 46% improvement in throughput with the new storage hardware. So that's good, right? There must have been some latent demand in the system, and now we're able to improve things quite a bit. But what about response time? Let's take a look at the next chart. Okay, now we're looking at response time, and we're looking at the before and after case. And again, we're using the compare feature, looking at 1 week of data. And here we're a little bit more disappointed. We only see 16% improvement, only about 0.3 milliseconds better. We expected more. We were expecting 40%, so we're not too happy with this. So what's the first thing we're going to do? We're going to go look at those dashboards and see if we can figure out if there's any clues as to what the problem is. So next chart, please. So here's the storage system dashboard. And what do we see? We see that the new storage box has a red dot for both pen time as well as command response delay. So that's a good clue that there's something up with the new storage. It's not really performing as expected. So next step is to kind of look more closely at the CMR before and after the migration. So let's drill down and see that. Let's go to the next chart. So what do we see? It shows that the pen CMR time increased by over a factor of 4 after the migration. That's a lot. That's 453%. Now, what do we know about CMR? We know that there's a couple of things that can cause elevated CMR. Some of them are things like overloaded host director ports, overloaded storage microprocessors, or misconfigured channels. Now, knowing that, chances are it's not the hardware at the storage. This is brand new hardware. So misconfiguration seems like a likely culprit. Maybe the channels weren't configured properly. So let's go to the next chart. So now we go over and we look at the, things like deferred vikon requests, and that's also available right from Vision. And we notice a big change here. All of a sudden, with the new hardware, we've got a 2,000% change in the number of deferred vikon. Now, it's not enough to cause it to be red or yellow, but it is a symptom of misconfiguration of the channel. So this is kind of the smoking gun that confirms our expectation that there was a channel issue. So let's go to the next chart. So what happens? They work with the storage vendor, and the customer is able to clear up the vikon configuration issue. Once they fixed it on December 2nd, you can see that the change in CMR time was cut in half. So all of a sudden, the CMR time was back down to a reasonable level for the particular BMAX3 hardware. The performance exception disappeared. The dashboard turned to all green now. We no longer had this red dot on the dashboard, so we fixed the problem, and it was confirmed by our IntelliMagic Vision software. So let's go to the next chart. So now what was the proof of the pudding? Now we compare after the configuration fix. Let's compare back to before not to the before case, but to the case. The before case, before the migration. Now we see the over 40% improvement in the response time. So we've exceeded the 40% improvement that was expected, and an absolute change of 0.8 of a millisecond. So now we're getting what we paid for. Everything is as expected, if not better than what the vendor said. So solved the problem, got the benefit that we expected. Next chart, please. So a storage migration is all well and good, but how do you know that how do you show the business that all that money and effort provided actual tangible benefit? This is the kind of chart that will help. Here you see that there is much less DASD usage across all of the service classes in the sysplex. Thus, the service classes will run more quickly and efficiently. That's the real bottom line. The storage upgrade really is no use unless it helps improve things on an operational level. So IntelliMagic Vision provides you a way to tie the storage performance back to your applications. Next slide, please. Now we're showing you the overall picture, the entire migration, the before and after picture. Now, if you just looked at this, you might say, well, yeah, things got better after the migration. But you may have been content, if you hadn't been looking at it carefully and had IntelliMagic Vision to tell you there was an issue, you may have been content with the 16% performance improvement and never actually looked for the vikon misconfiguration. At least you wouldn't look at it until it actually caused an outage or some kind of major disruption. So here's an example of how you prevent issues by going through and being proactive with IntelliMagic Vision. Next chart, please. So visibility, that's one of the big operational benefits. Again, you found the issue and the specific metric was flagged quickly. You didn't have to go hunting. The compare function was very powerful. It helps you quantify the magnitude of the problem and the actual solution. It validated the solution. And then the correlation. You can see how storage metrics were compared to both system metrics and also the channel metrics. So the channel metrics comparison helped you find evidence what the problem was, and then the system metrics correlation to help you prove the benefit of the new storage hardware. Okay, let's move to the next slide, please. I'm going to try to pick up the pace here a little bit. So the next one is related to replication, and it's global mirror RPO spikes. So this is IBM Global Mirror. And one of the trickier problems facing storage administrators is managing asynchronous replications, like IBM Global Mirror. With asynchronous replication, the disaster recovery site is by nature somewhat behind the primary. This is acceptable, but if things fall too far behind, the mirror could be suspended, which may be considered an outage. This case study will show you how IntelliMagic Vision can be used to provide visibility to the status of global mirror replication in a GDPS, globally dispersed parallel sysplex environment. Data about the global mirror sessions is recorded in SMF type 105 records, which IntelliMagic Vision can analyze. By observing patterns and using drill downs, the root cause of the issue may be determined. So let's move to the next slide, please. So this chart shows you the situation. What was happening is you're getting periodic spikes in the RPO, or recovery point objective. And it was being seen for one of the active global mirror sessions. So this is sometimes unacceptable. If you're getting these spikes in RPO, you may have a service level objective on the RPO and you may be exceeding it. So let's go to the next slide, please. So we can analyze that data, we can drill down, and we can see how it looks by day of the week. And what we notice here is all these spikes, for the most part, the major spikes are happening on Sunday. So primarily Sunday is our issue, so we can kind of narrow things down a bit. Next slide. So from that slide, we can easily drill down and see the spikes in Outofsync tracks. So we do see a high number of out-of-sync tracks when the RPO spikes. Maybe the storage is overloaded. That's one possible cause. We also see that global mirror is briefly suspended when the RPO spikes, and the suspended volumes are all on one DSS, one disk storage systems. Now we notice that this, because of configuration information we have, this storage system is a Metro mirror target in a Metro global mirror environment. So this helps us figure out, where the data that's going into the storage box is coming from, so we can see if there's some kind of an imbalance. So let's move to the next chart, please. Okay, so we looked at from a different point of view, we looked at how much data, replication data, was going into that particular storage box, and how much data was being sent. And that's where we saw an imbalance. We saw that the Metro mirror activity writing to the disk storage system spikes to around 900 to 1100 megabytes per second, and that's happening during the suspense. But the global mirror send from that storage box to its tertiary is only running at 400 megabytes per second. This is a typical symptom that you'll see when the network is not adequately provisioned. So in this case, we were able to recommend that we provide more bandwidth between the Metro mirror target and the global mirror target. If we provide more bandwidth, we'll be able to open up that pipe, and we'll be able to be in better balance with the right spikes coming from the primary storage. So again, if the RPO spikes are unacceptable, we provide guidance to find a quick resolution. Next chart, please. So again, visibility. That's a common theme we have. We were able to find the issue, flag it, and quickly resolve it. We can see when exactly the problem was occurring, and we can see what caused it. We saw the imbalance. And then we could drill down, and we can identify which the storage system is affected and help determine that root cause. So all that is very rapid. Okay, next slide, please. Okay, I'm going to shift gears here now and talk a little bit about virtual tape. And the question here is your virtual tape replication meeting your service level agreement? That's the question. Next slide, please. So, one of the things you might be interested in is how many VTVs are being replicated, or virtual tape volumes are being replicated. It's interesting. This is, again, for Oracle VSM in this particular case, but we do support other types of virtual tape, including the TS7700. But anyway, how many VTVs are being replicated is interesting, but really how long it's taking and if they're all being replicated the way you expect, that's really important. For example, if you're looking for synchronous replication and you're getting asynchronous replication, you'd want to know that. Next slide, please. So we do provide a dashboard, and this dashboard shows us the health of the synchronous virtual tape volumes, replication, and everything looks green, so it's all good. But let's look at some charts to dig into this a little bit more deeply. Next slide, please. So we see this spike here. The number of virtual tape volumes is interesting. It's an interesting spike. And it shows maybe we have a bottleneck in the system here. This might be the end of a batch run. If you look at the timing, it's 5 a.m. And maybe something like HSM is doing a bunch of backups. But if you have too much of this activity, it could affect your replication. If there's too many virtual tape volumes that need to be replicated to a second site, that could cause some problems. So spreading this workload out could be a good way to reduce this particular peak. Let's go to the next slide. Now we switch from number of virtual tape volumes to the size of the virtual tape volumes. This is useful for a bandwidth calculation. We can compute to see how much bandwidth is going on. We see almost 16 gigabytes of data during the 15-minute interval at 5 a.m. We could also look at things like, with other charts. We could look at things like replication throughput versus the VTV size. One of the things you should notice, small VTVs have a higher overhead, and so lots of small VTVs may have more overhead than a few large ones. Next slide, please. Next, we look at delays, and we're not seeing a lot of sync replication delays, so that's good. The data is replicated while it's being written by the application. So, this is healthy. So let's move to the next slide, please. There's no delays. That's good. But what we notice here is we see some VTVs, even though we're calling for synchronous replication, we're seeing some VTVs being replicated asynchronously. This is not what you expect. You're expecting synchronous replication. Here you can find easily from here exactly which VTVs are involved in this asynchronous replication. And so from here we can easily find specifically which VTVs are being replicated asynchronously. So now if your synchronous replication is mandatory, you need to ensure that it's enforced and monitored. So if some of them are being replicated asynchronously, this is where you need to figure out why. In this particular instance, they found out why. The synchronous links were down, so the VTVs that were in transit did not get replicated synchronously and reverted to async. So this was a clear example of looking at this data, looking at your replication data, you see that you have a physical problem with synchronous links. Next chart, please. Now, if synchronous replication, next chart, please. I think I already covered this one. So exposure. Until all your data is in a second location or on separate media, you remain exposed to data loss in the event of a serious outage. So how do you monitor this? Some customers require data to be on 2 multi-volume cartridges. Now, replication is a way to reduce your exposure significantly, but Vision can be used to help you calculate your exposure time. And the exposure time is essentially the time between your dismount and the tape being migrated. So next chart, please. So in this case, we see a few VTVs that are exposed, and we need to look at this chart regularly to see if our SLAs are being met. So if we see this situation and we have a requirement for our exposure time and we're exceeding it, this is one way we can make sure that we have a healthy environment. Next slide, please. So identifying the volume is the first task. And it's really, you can't do it without vision. So the reason for the exposure being high, it could be slow replication, slow migration. If it's slow migration, then it could be not enough migration tasks are defined. It could be no free back-end tape drive, all busy with something else. It could be the wrong management class. This manages migration out of the VSM buffer. It may be something else, and then maybe you need to involve Oracle if you have VSM tape. And then if replication is used, exposure would be exposure as reported by Vision would take that into account. So that's basically just a kind of a high level of how you can use IntelliMagic Vision, in this case with VSM tape, but we have analogous capabilities when it comes to other tape libraries such as the IBM TS7700. So that's about it. I'm going to turn it over back to Brent, and he's going to see if we have any questions. We still have 3 minutes.
Good. Thank you, Lee, very much for that. We do have a couple of minutes. I'm just going to take one question at this point that was asked, and I'll answer it, and we'll see if you have anything to add, Lee. But it was really about the product itself. When you use the user interface, how do the drill downs work? And maybe reading into it a little bit, some of the customization options. And so, you know, the easiest way to see how that works is, of course, to send us some data, and we'll load it on there and actually give you some logons as kind of a proof of concept. It's quite fast and easy to be able to do that. But there are multiple options on how you drill down. Again, we feel that this is part of the value of, you know, the DOS expert knowledge in there of knowing and anticipating where you want to go when certain conditions happen. So there's a variety of drill downs available in the user interface that you can select to see things from a lot of different dimensions, from a logical view and time views and different types of charts. And there's actually a high degree of customization in the charts that are available as well, just with a few clicks, no coding required. You can change the scale, you can add additional metrics on the chart, so on and so forth. Do you have other comments on those kind of issues, Lee?
No, the only, I mean, there are drill down buttons on that interface, and you just click on a line, and it takes you to the next chart. And then on the web interface, which I didn't show you slides from that, it's also similar. You just click on a line on the chart, and it brings up all your drill down options. You select the one you want, and boom, a new chart appears. So it's really very, very easy to do drill downs. And like Brent said, you can even go in there and say, hey, I don't want to look at connect time, I want to look at disconnect time, and you can change the variable, or I can say I want to look at connect time correlated with some other metric, and I can add a second metric to a chart. So all this is right there available to you with just a few clicks. And you know, if you really wanted a good demo of the software in action, we can always set that up. That's easy enough to do. You know, a half-hour webinar to do that. And I believe at the Share conference, if anybody's going to be there, we'll have a vendor session where we'll actually be demoing the software using some of these same test cases, but in a demo mode.
Right. And the other nice thing about actually sending us some data and having us load it on the software as a service platform is that if you've had any problems over the last 12 months, that's the beautiful thing about RMF and SMF is you keep all the historical data. So send us the data from prior to that incident, and we can actually determine whether the predictive analytics would have been giving you some warnings prior to the incident occurring. So anyway, there's a lot of different things we can do like that, but we are at the top of the hour, so I'll wrap it up here. Thank you, everyone, for your time. You will get a copy of this presentation after it's over. The marketing group will send out some links for that. So thank you very much. Thank you, Lee.
Thank you.